Okay, thank you all very much for joining us again. We are starting this afternoon with our short paper presentations, which are slightly longer than the short paper presentations we had first thing. So we're looking at roughly 20 minutes presentation and then a 10-minute Q&A. And what I ask is for those of you that are in the room, when you ask your questions, give me a moment because I'll have to repeat them so they're on the recording and so that Seth can actually hear what you're going to say. So our first short paper today is by Seth Hart on the modern synthesis and Platonic theism. Can you just double check you can hear us okay, Seth?
Yes.
Brilliant. And when you're ready, if you wish to, you can share any slides you've got. But over to you.
Sure thing. And appreciate you having me. I really wish I could have been over there. A series of unfortunate events has prevented that. Is that showing up?
It is, yes.
Great. I'll go ahead and start then. The arrival of the modern synthesis radically shifted the focus of biology to the development of mathematical models that could accurately map the changing genotypic landscapes of populations. And even with the onset of the extended synthesis, these models continue to be an integral aspect of evolutionary research. Optimality models, fitness landscapes, and niche modeling are capable of synthesizing massive sets of data in order to generate pictures of evolutionary trajectories. Yet while biologists freely employ these heuristically valuable methods, they have little time to philosophically reflect on what these models actually convey. What, for instance, is the common feature that fitness is measuring? How are we to interpret the counterfactual possibilities presented by the various peaks of fitness landscapes? What does it mean to fill a niche? Terms such as niche, adaptation, natural selection, and fitness are core to the explanatory structure of the modern synthesis. Yet, as John Rice notes, unlike fundamental terms in physics, such as mass, energy, and velocity, such terms have no generally agreed on meaning. While philosophers continue their tireless inquiry into these perplexing questions, I will propose the theologian might also find them of interest. In particular, they are a promising area of inquiry for classical theists, and the Platonic theist tradition may offer a unifying answer to each of these questions in its concept of the good as a universal teleological cause. There is then a possible theological reading of the information provided by population genetics and the related fields of biology, one that offers a natural synthesis of the great classical and medieval tradition with modern biology. I will begin by briefly looking at just a few examples, specifically narrowing in on the concept of fitness. Then I will define what is meant by Platonic theism, before briefly suggesting a theological reading of the biological data. One common explanatory strategy among contemporary biologists is the engineering model, or optimality modeling. The modeling procedure occurs in this manner. The range of possible alternative states for a trait is mapped in such a way that the scientist can determine variable fitness gradations. From there, the scientist determines the optimal range for the feature within its ecological niche. These models are then testable against the actual morphology and activity of the organisms. If the model matches observation, then behavioral and morphological features are determined to be optimally fit for its ecological niche and therefore an adaptive response to the environment. A locus classicus of this approach is Crawford Holling's research into mantis predatory behavior. A mantis's grasping capabilities are maximized if directed at prey of a certain diameter. Subsequent studies have indeed confirmed that mantises target prey within this optimal range. A more recent example has been the formalization of Darwinism into the mathematical framework of Alan Graffin. Graffin defines an objective function as an organism's individual fitness, and phenotypes that maximize the objective function are called optimal and said to, quote, solve the optimization program. In commenting upon the project, Samir Okasha remarks, the objective function represents a goal of the individual behavior, in the sense that if individuals are well adapted, they will behave as if they are trying to maximize the function. Okasha's comments reveal the overtly teleological character of these explanations. As philosopher Michael Katz notes, the prevalence of optimality models in biological explanation provides a good example of the role played by teleology in research programs. Another common feature of evolutionary explanations, one I'm sure you're probably more familiar with, is the fitness or adaptive landscape. The origins of this concept date back to Sewell Wright and the very foundations of the modern synthesis. Wright visualized the evolution of organisms by natural selection as a topography filled with adaptive peaks and valleys. Peaks in this illustration represent maximal fitness values for a given genotype, phenotype, or allele frequency, while valleys represent lower grades of fitness. They are, according to Daniel Dennett, a standard imagination prosthesis for evolutionary theorists. It has proven its worth in literally thousands of applications, including many outside evolutionary theory, end quote. David McCandlish echoes this point, stating, the fitness landscape is one of the most influential concepts in evolutionary biology, end quote. The basic, though by no means universal rule of these models is that populations will ascend upward via the nearest adaptive peak to levels of higher fitness. In other words, natural selection explores those peaks local to it. While most illustrations are either 2 or 3-dimensional for the sake of visualization and simplicity, there is no restriction on the number of dimensions one could theoretically include. And in fact, these higher dimensional models present some topological features qualitatively different from the familiar 3-dimensional terrain. While some biologists have deemed adaptive landscapes as purely heuristic, George McGee has shown that they, quote, can be put into actual analytic practice through the use of theoretical morphospaces. Here again, the teleological implications are apparent. As Okasha has remarked, quote, the notion that natural selection pushes populations up adaptive peaks suggests a quasi-teleological view of evolution as a goal-directed process. This ties in with what we call agential thinking, in which the process of natural selection is analogized to an agent's deliberate choice. Rice has similarly remarked that, quote, teleology is exemplified by Wright's metaphor of an adaptive landscape. While both authors attempt to bypass the teleological implications of the landscapes, there may be a more fundamental problem in avoiding such teleological implications, namely that the teleology derives not from the landscape, but from the very concept of fitness itself. According to Lewontin's influential schema, the conditions for natural selection involve 3 aspects: trait variation, heritability, and fitness differentiation. It is generally agreed that without these 3 cogs, the engine of natural selection fails to run. Intuitively, the latter concept, fitness, seems relatively uncomplicated. There must exist a certain fit between organisms and their environment for the organism to survive, and those individuals whose features best provide for the needs of survival and reproduction will outcompete other organisms. As such, much of the relevant literature on fitness selection views it as analogous to a Newtonian force in competition with other forces, such as drift. Moreover, fitness is included as a key variable in the mathematics of population genetics. Yet the seemingly straightforward notion has generated no shortage of debate concerning its definition and its causal role. Like Augustine's troubled inquiry into time, biologists only seem to know what fitness is until they are asked to define it. Unfortunately, philosophers of science have so far failed to offer much assistance in offering an illuminating consensus in what the concept properly signifies. The issue does not bode well for the modern synthesis, for as Santiago Ginobili warns, without a clear understanding, quote, evolutionary explanations would become incomplete. The possession of a trait and reproductive success would cease to be causally and relate causally, and explanations would no longer rise above the status of mere statistical correlation between the possession of a trait and reproductive success. In other words, a recognition of fitness differences allows a biologist to claim trait X causes reproductive success rather than merely trait X correlates with reproductive success. Because of its importance, Ramsey and Pence note, few concepts have elicited such a long and heated debate in the philosophy of biology as that of fitness. I shall briefly list only 2 problems currently plaguing philosophers. I have labeled the first problem the problem of nominalism. The sheer quantity of different features that confer fitness make any attempt to discover some unifying property a seemingly impossible task. What similarities are shared between the white fur of a polar bear and the sharp teeth of a shark so that both might be considered bearers of increased fitness? While both might produce the same effects, namely survival and increased reproduction, it is difficult to see how they can be treated as a singular cause. As Ginobili writes further, the problem is that there is no specific physical property that is uniquely relevant for the determination of ecological fitness and hence could provide a basis for unification. A second issue I label the problem of tautology. One of the oldest accusations against natural selection is that it reduces to pure tautology, and it is an issue that has dogged the theory ever since. In fact, Alex Rosenberg, who wrote the Stanford Encyclopedia entry for fitness, admits that natural selection is, quote, often mistaken even by biologists for an empirically empty theory unconnected with other theories in natural science. The issue arises from the fact that fitness is invoked to explain differential reproduction, yet it is often treated as identical to differential reproduction. As Michael Hanby succinctly asserts, survival explains fitness, and fitness explains survival. The fit are simultaneously both the cause and effect of differential reproduction. Attempts to avoid this problem have been described as, quote, torturous. As a simplified summary, the closer one identifies fitness differentials to the cause of selection, the more one runs into the problem of nominalism. Yet the more one aligns fitness with the effects of selection, the more the issue of tautology emerges. Fitness, therefore, seems to be trapped between the twin horns of a perilous dilemma. Because of these issues, many philosophers have even called for abandoning any causal notion of fitness and natural selection. They offer instead a statistical interpretation of fitness, which, in their own words, quote, eliminates evolutionary process. That is, it shows that earlier and later stages of a population fitness or adaptedness in an evolutionary process should not be considered stages of the unfolding of a fundamental process. Yet one less drastic solution to the problem of defining fitness would be to view it as teleological, I'm proposing. It is perhaps suggestive that Darwin himself may have opted for this very strategy. As James Lennox has shown, Darwin often appealed to the end or purpose as the reason behind a trait selection. In fact, Darwin often used the term final cause in his argumentation and consistently maintained that natural selection acts for the good of each being and that its products are present for various functions, purposes, and ends. Lennox summarizes Darwin's thought as follows, quote, the beneficial consequences of a variation explain why it is selectively favored. He adds, as in domestic selection, the good served by a variation continues to be causally relevant to its increasing frequency or continued presence in a population. It is possible, then, to treat an organism's fitness as the product of multiple teleologically related factors. One, the development of a creature's essential traits, and I can spell that out. Two, the ability of those traits to accomplish their function within their given environment. Three, the performance of a given function assisting in the development and homeostasis of the entire organism. And four, the reproductive success of the organism. Each component is for the sake of the next component in the list. Thus, there is a teleological ordering of the four aspects of fitness, with the final component having explanatory priority, as Francisco Ayala notes in his treatments of biological teleology. Reproductive success is the end that determines and orders all prior goals. These are but a few issues that seem to suggest that teleological explanations are not merely heuristic, but necessary parts of biology, and that these explanations denote objective features of reality. This brings me to my second point, namely, given these conclusions, there is a fruitful theological reading of the biological data presented by Platonic Theism. But first, what do I mean by Platonic Theism? I coined this label to broadly denote the tradition, beginning with Plato, that identifies God with the form or idea of the good. Thus, it incorporates thinkers from a variety of traditions, including Plotinus, Augustine, Proclus, Avicenna, Thomas Aquinas, and perhaps even Aristotle to some degree. For Plato, the idea of the good takes center stage in the Republic, acting as the highest unitive principle for all the other forms. While the good is also positioned as the font of truth and being, its role as the ultimate goal of all action takes equal precedent. As Lord Gerson notes, the good's privileged status as the font and goal of reality ensures that Plato's ancient interpreters equated it with talk of the divine. While Plato himself never explicitly equates the two, by situating the good as the source of all knowledge and existence and placing it beyond even being itself, it seems fair to suppose the univocal voice of antiquity was correct in its assertion of the two's identity. Unsurprisingly, Christianity and Islam found the Platonic system, whereby God serves as both source and end, to be a welcome pagan ally. For instance, Augustine locates the final cause of volitional efficient causes in their ultimate source. For, as he famously states, "You have made us for yourselves, and restless is our heart until it rests in you." For these thinkers, creaturely goodness derives from divine goodness, from God himself, as the idea or form of the good, acted as the measure of goodness for creaturely beings. Put in its simplest form, we partake in goodness, whereas God is goodness simpliciter. Thus, the very act of a creature seeking its own good is identical to its pursuit of greater participation with God. Moreover, even while creaturely ends are wildly distinct, they are each directed to God, the one good that is good essentially, rather than via participation. In the elegant words of Jan Ertsen, quote, "The things which are as it were dispersed, insofar as they are ordained to their own different ends, are gathered in the directedness to this final end." He continues, "Because God is the universal good, every creature naturally loves him more than it does itself." What then does this have to do with biology? If there are objective goods for biological organisms, a Platonic reading would entail seeing these goods as reflections and participation in God's own goodness. In natural selection's orientation toward these goods, the Platonist might read these as the striving of nature towards its divine source and end. In other words, a biological world filled with creatures directed towards good ends is exactly what a Platonic theist would expect to find from our investigations. I began this talk by noting that the central terms of evolutionary biology lack clear definition. I end by proposing such a definition may find a philosophical foundation in Platonism. Ecological niches, for instance, would be defined as the spaces in which the goods of a creature can be actualized in a given environmental context. Fitness landscapes would prove to be not merely valuable heuristic devices, but the mapping out of actual creaturely goods and the movement of organisms toward peaks corresponding to the highest actualization of the goods proper to their mode of being. Optimality modeling would prove to be as reliable as it has been because it can identify objective ends that creatures actively endeavor towards, ends corresponding ad extra to what God is ad intra. In all these cases, organisms seek their own good, a good given by and directed back toward their divine source. Evolution then might be then seen as an act of worship, a striving towards God and an attempt to replicate the Creator's goodness, however imperfectly, by his creation. Of course, none of this demands that biology adopt Platonic theism. My conclusions should not be confused with an apologetic. Rather, the more modest proposal is that Platonic theism provides a welcome metaphysical framework for understanding these biological models, one that opens up new, or perhaps old, conversations about the relationship between theology and biology. Undoubtedly, many questions could be levied against this proposal, as it would be a radical departure from the assumed metaphysics of biology. Nevertheless, I propose the advantages of this framework for interpreting biology prove its value, and as such, is worthy of further consideration by theologian, philosopher, and biologist alike. Thank you.
Brilliant. Thank you, Seth. Right, so if you've got short questions, I'm happy to repeat them. If you've got big, deep and meaningful questions, if you want to come up and talk at the camera, and then Seth can see you as well, rather than me trying to garble your question. Andrew.
Yeah, I have a very short question. Thank you for a very interesting presentation. My question is the good also defining natural elimination, which is the flip side to natural selection?
So the question was, is the good also defining natural elimination?
Yeah, so this is part of a bigger project. And one of the things that I'm looking at is whether or not we need to view natural selection as selection for or selection against, which has been kind of a big debate. Rosenberg, who I brought up, opts for the selection against model. Whereas in what I'm opting for is a selection for model, in which that properly, good traits that are selected, so that the active principle needs to be seen on the good provided by the traits themselves. So I'd say no. So natural selection, we need to see natural selection as the active part of natural selection, and the causation being the goods provided by organisms, so that there is no actual technical selection against in that capacity. I hope that answers your question. Does that get at it?
Well, I was really getting at whether the good is also driving things to be eliminated.
So,
okay.
Did you hear that? Okay, Seth.
No, sorry. One more time.
So whether the good is
driving things to be eliminated.
Is driving things to be eliminated.
Yeah, so that would be one of the implications would be, yes, is that less fit features are being eliminated. I think that's any evolutionary theodicy has to deal with that. And so I actually have independent work on how you deal with that. But yes, the short answer would be that.
Yeah.
Have you read Erasmus Darwin?
Yes, parts.
And Temple of Nature, which is Platonic, I think, and Erasmus uses nature maybe to replace God in his description. It's Platonic. You were talking about good, and I wonder whether that affected that use of nature, which we still find in Darwin. It takes that locus of God.
Could you repeat the last part? I heard Erasmus Darwin, but I've struggled after that.
Sorry,
This side, yeah. Erasmus Darwin, the Temple of Nature, is Platonic, but nature takes the place of God, or maybe the place of good.
Right. Yeah. So I struggle to remember exactly what or how Erasmus phrased it. But so what you would need to end up there, and perhaps you can. My immediate sense of that would be that you can't have a complete equivalence with the natural world. Otherwise, there'd be no teleological end. There'd be nothing to strive toward in that sense. There needs to be some sort of unactualized end.
I think my point is, I think that influenced Darwin. So Darwin's language.
Oh, I see. I see.
And that fills the gap, because they both, through personal circumstances, rejected a theist God, certainly. Mm-hmm. Erasmus's wife yet died young, and of course Darwin's daughter died.
Right.
But nature provides that word that they can use in that place in a Platonic system.
Right. Yeah. Okay. Interesting. I appreciate that. Yeah. I also appreciate Wallace. Wallace's take as well, the very Platonic model. So these were obviously floating around quite a bit, but thank you so much. It's been far too long since I've read and tried to interpret it through that Platonic lens. So I appreciate that.
Any other questions? Yeah. It's easier if you come up and talk at the webcam.
Hello, thank you so much, Mr. Hart, for that talk. I had a question about the tautological problem that you proposed, and I was wondering if you could talk a bit more about that in terms of fitness differences and it being a problem because it's both cause and effect. And I'm just wondering, where could a possible hermeneutic come into this, in which you have kind of an ontological status of an open-ended self-constituting process? It's not actually a problem, it's both cause and effect, because there's an emergent property of these two things feeding back into each other, if that makes sense.
Yeah. So that's an interesting proposal. So I'll go ahead and repeat. So what the problem was essentially is that if we identify it as a cause, right, then I use the illustration of the white of a polar bear's fur and the sharpness of a shark's tooth. There's no physical similarity there. What's the same there is the effect. Which is that it produces increased survival and reproductive success. So if we're going to identify fitness as a cause, if we want to identify it as the cause, there's no sort of physical basis by which to treat it as a unified physical cause. There's no unification there. So in a scientific explanation, you want some sort of unification with your explanations. But if the closer that's the problem of nominalism. With the problem of tautology is as soon as we identify it with the effects, which are unified, survival and reproduction, then all of a sudden it becomes tautological. You can't explain an effect by itself. It needs some sort of separate cause. And so that's the problem of tautology sort of writ large. And so that's the sort of twin horns of dilemma that fitness is sort of wavering between. And then you see this when you read the literature. Now, when you talk about, I wasn't quite sure what you meant by like a sort of emergent property. So could you explain that a bit more? Sorry, Rebecca.
Yeah, no, sorry. I think that actually answers my question. Maybe because my question is kind of ill-founded in a sense, because I just mean that if you're going to talk about cause and effect, it seems that there's also kind of a very, this presumes a type of efficient cause, if you're looking at Aristotle's four causes. Yeah. It's a very linear causal effect. Mm-hmm. But it sounds like that's what you're looking at because it's within the specific field of biology. So I think that actually answers my question.
Yeah. Absolutely, because, like I used Richard Lewontin's three, you need three aspects, one being fitness differentiation. He's treating that as a cause. And so that's a sort of standard view of natural selection. If we don't want to take this sort of statistical model that I brought up at the end, where natural selection isn't really a cause. If we want to preserve it as a sort of, in that role, we need to somehow identify fitness differentials as part of that cause. So which gets into the problem of nominalism, if that makes sense.
Yes, that does. Thank you.
Yeah, absolutely.
Thank you. Any other questions for the floor? Yeah, do you want to?
Pretty short one.
Okay.
What's the value in having a definition of fitness?
What's the value in having a definition of fitness?
Right. It's kind of what I was just explaining, right? We want to know what we're talking about whenever we talk about fitness, because it's part of the sort of causal, the three cogs that form the engine of natural selection. So having a definition of, well, what do we mean whenever we talk about?
Do we need a definition to know what we're talking about?
Do we need a definition to know what we're talking about?
So that's a different question. So quite a few have opted, because of all the problems, to just treat it as a primitive, which I see as a philosophical equivalent of waving a white flag at the problem. I do believe in primitives, but in this case, I think there's a better solution than just treating it as, well, as Stephen Stearns once defined fitness in a biological textbook, something every biologist knows, but no one can define. That was that actual definition of fitness. Because they're just this sort of intuitive grasp that we know what it is. But I do, and we do see it as something. It's like we can use it as part of a causal explanation. Well, the reason this polar bear survived and this one did not is because it had higher fitness. We recognize sort of intuitively why. And I just sort of want to work that out. And without opting for it as a primitive, I'm saying there is a way of defining it that actually works, but it has to incorporate teleology. And I think that's sort of in the background. We are sort of subconscious Aristotelians in that sense. We're sort of, and I'm trying to out us in that sense.
Thank you. Have we got any other questions for Seth? Brilliant. Oh, yeah.
Well, just a brief one. When I asked a medic what is the purpose of kidneys, and the answer was to purify the blood, and then I found out that the medic was an atheist. The answer should have been, there are no purposes for either kidneys or humans, but those without kidneys die, so that's why the remainder have kidneys. I think I'm right about that. And does that describe your point about fitness?
Yeah, and I like what you did. So there's actually they're called etiologists, and that's to say, well, when we use language of purpose, all we're talking about is somehow in past populations, creatures that had kidneys, I think was the example you used, survived, and those that did not died off. And so when I say the kidneys are for function X, all I'm actually saying is that it did this in the past, and that somehow promoted survival and reproduction in the past. So yeah, I think that is what I'm saying. But what I'm trying to get at is that more fundamental than that, the engine of natural selection itself doesn't make sense unless you have real teleology sort of programmed into it from the foundation. So I don't think the etiologists can get around it just by appealing to to past selection effects, because that selection itself, I'm trying to say, is itself teleological. So I think you're right on board there with saying, yes, that's kind of what I'm getting at. Now, I would say that I'm not saying you have to, as an atheist, avoid teleological explanations. Although I do think it is quite natural as theists, Platonic theists, like I pointed out, Platonic theists would naturally expect this out of the world. It's, in a way, to use scientific language, it's a correct prediction from Platonic theism. So it provides a way of viewing it. But there are people like Thomas Nagel who are teleological realists and they're atheists. So they would say, yeah, the kidney does have a function, but God does not exist. So, I mean, that's not something I try to deal with here. So.
Thank you.
Thank you very much for your time, Seth. I think we'll all give you another round of applause. I think.
Thank you.